Good morning, everyone. I'm Mr. Nixon Tudorako, your mathematics teacher, and welcome to our virtual mathematics class. So our lesson for this week, for the fourth week, is all about the part 2 of the geometric sequences. So to start with, allow me to give to you the objectives for this week's lesson. So you will be able to, letter A, define geometric means. Letter B, find the geometric means and end term of the geometric sequence. And for letter C, for the last one, appreciate the importance of geometric sequence in real life. Now, what are geometric means? Now, we call terms between any two non-consecutive terms of a geometric sequence geometric means. Now, to solve for the geometric means of a given geometric sequence, the formula for the end term of the geometric sequence is also used. So what is that formula? So the formula is a sub n is equal to a sub 1 times r, or the common ratio, raised to the quantity n minus 1. So where n is the number of the term, or the term number, and a sub 1 is the first term. Now let's have an illustrative example. Number 1. Given the first term 4 and the last term 64, insert 3 geometric means. So for its solution, for step 1, we need to find first the common ratio. Now, how are we going to find the common ratio? So we're going to let 4 as our first term, and since we will be inserting 3 geometric means, our fifth term now will become 64. So what are those geometric means to be inserted? So these are a sub 2, a sub 3, and a sub 4. Now the formula is a sub n is equal to the first term multiplied by the common ratio raised to the quantity n minus 1. So let's substitute. So for our a sub n, that will become our fifth term, which is 64, which is equal to the first term is 4 multiplied by the common ratio raised to, what is our n? Since the last term here is the fifth term, so Rn will become 5 minus 1. Okay? So we have now 64 is equal to 4 times the common ratio raised to 4, since 5 minus 1 will give us 4. Then, to get rid of 4 in our r raised to 4, we're going to multiply both sides by 1/4, or you just simply divide both sides by 4. So we'll be having 64 divided by 4 is equal to 4r raised to 4 divided by 4. So 4 divided by 4 is 1, so we only have r raised to 4, which is equal to 16. Yes, the quotient of dividing 64 by 4. Now, to simplify or to find the value of our common ratio, we can express this in exponential form, wherein the exponent will become 4. So what is that? Yes, very good. So that is 2 raised to 4 is equal to r raised to 4. Since 2 times 2 times 2 times 2 will give us 16, so we can express that also in exponential form. Since the exponents are the same, the value now of r is equal to positive or negative 2. Why? So it's simply like this. If you have 2 times 2 times 2 times 2 will give you 16. In the same manner, negative 2 times negative 2 times negative 2 times negative 2 will also give us 16. Or we can also show the solution in this manner. To get rid of 4 in our equation here, what we're going to do is to get the 4th root of r raised to 4 as well as 16. So the 4th root of r raised to 4 is equal to r, and the 4th root of 16 is positive or negative 2. Meaning, our common ratio is positive or negative 2. So let us proceed to the next step. Let us proceed to the second step of our solution. Since we already knew that the value of the common ratio is positive or negative 2, what we're going to do is to multiply the first term by our common ratio to get the first geometric mean. Then multiply again by the common ratio to get the next geometric mean, and multiply again by 2 to get the last geometric mean. Okay? So same process for the common ratio, which is negative 2. So we will be multiplying the first term by negative 2, then multiply again by negative 2, then for the last time multiply again by negative 2. Alright? So we have now, for the second term, or a sub 2, since the first term is 4, we will be multiplying that by 2. So we have now 8. Then for the third term, that is 8 times 2. And that will give us 16. Then next, 16 times 2 will give us 32. Okay. So same goes with the negative common ratio. So if we have 4 times negative 2, that will give us negative 8. And negative 8 times negative 2 will give us 16. Then lastly, we have 16 times negative 2 will give us negative 32. So therefore, the 3 geometric means now are 8, 16, 32 for the common ratios is positive 2, and for the common ratio, which is negative 2, that will give us the geometric means of negative 8, 16, negative 32. Now let us proceed to illustrative example number 2. Given the first term 5 and the last term 625, insert 2 geometric means. And for the solution, the first step is find the common ratio. So to find the common ratio, so we will be using the first term, which is 5, and the last term, which is 625, since we will be inserting 2 geometric means, and those are a sub 2 and a sub 3. Okay? So using the formula a sub n is equal to a sub 1, which is the first term, multiplied by the common ratio, raised to the quantity n minus 1. We have now 625, which is our fourth term, is equal to the first term, which is 5, multiplied by the common ratio, raised to the quantity 4 minus 1. But 4 minus 1 here will become 3. So we will be having 625 is equal to 5r cubed. So to simplify this further, we can divide both sides of the equation by 5. So we have now 625 divided by 5 is equal to 5r cubed divided by 5. So simply, we have now 625 divided by 5 is 125, which is equal to r cubed. Now, to find the value of r, we can show this, or we can rewrite 125 in exponential form. And that is 5 cubed is equal to r cubed, meaning the value of r here is equal to 5. So it's only positive. Why? Because the exponent here is an odd number. So meaning to say, if you will be using negative 5, this will become negative 5 times negative 5 is positive 25 times negative 5 is negative 25, which is not the correct common ratio. Or you can also show this by using this solution. You can get the cube root of 125, and on the other side you're going to get also the cube root of r cubed. So similarly, it will give you the common ratio, which is 5. Okay. Now, for this step, to what we're going to do, since we already got the common ratio, which is 5, we're going to multiply the first term by our common ratio to get the first geometric mean, and multiply again by 5 to get the second geometric mean. So meaning that is a sub 2 is equal to 5 times 5, which is 25. Then a cubed, which is 25 times 5, is 125. So therefore, the two geometric means are 25 and 125. So we got a geometric sequence of 5, 25, 125, 625. Clear? So let us proceed with our illustrative example number 3. So what is the eighth term of the geometric sequence? 1, 2, 9, and so on. So primarily, we must be able to identify what is the first term, what is the common ratio, and what is the value of n. Okay? Since the first term now is 1, what is the common ratio? That is 3. It came from dividing the second term by the first, since we already knew that this is an example of a geometric sequence. So 3 divided by 1 will give us 3. And for n, that is the eighth term. Okay? So let us continue. So using the formula a sub n is equal to a sub 1 multiplied by the common ratio raised to n minus 1, we can now substitute the value of the first term, the common ratio, and the n. So what is our a sub n? A sub n now will become a sub 8, since we are finding the 8th term. So we have now a sub 8 is equal to the first term, which is 1, multiplied by the common ratio raised to the quantity 8 minus 1. So what we're going to do is to simplify first 8 minus 1. Okay? So we have now a sub 8 is equal to 1 multiplied by 3 raised to 7. So what we're going to do is to get first 3 raised to 7. It's not 1 times 3. So we start first with exponent. So what is 3 raised to 7? Very good. That is 2,187. Multiplying that, so we have a sub 8, which is equal to 2,187. So therefore, the 8th term of the geometric sequence is 2,187. Okay, so that's all for today, and don't forget, honesty is the best policy, and thank you. Happy learning.